Yes, dear friends, today I will take the topic movement of inertia. While learning Newton laws of motion, we learnt about inertia. Inertia, I told you the property of body by virtue of which body opposes any change in state of rest or state of linear motion. But what is moment of inertia? Now we are learning about rotatory motion. In last topic I told you torque and momentum, and in one topic I taught angular velocity. So our motion is not only linear. Our motion, we have so many motion which are circular. So what is inertia? I told you property of body by virtue of which body opposes any change in state of rest or state of linear motion. Now what is moment of inertia? Now it does not only depend on, you see, mass of body or single definition. Moment of inertia of a rotating body. We define moment of inertia in rotatory motion, circular motion. So the property of body which opposes any change in state of rest or state of rotatory motion. Rotatory motion is called moment of inertia. Moment of inertia. Property of body which opposes any change in state of rest or state of rotatory motion. You see, you start the fan of your room, that starts rotating initially with a smaller speed and gradually pick up the speed and run at full speed after some time. What is that? This is not, we does not allow the fan to pick the speed at once. That is moment of inertia of the fan. Now when we switch off the fan, it does not stop at once. What is that? Which keeps the fan rotating when no current is passing through that? That is moment of inertia. I hope you have got my point. Actually, physics has to be understood properly. Property, the spelling property of body, property of body by virtue of which, by virtue of which body, opposes any change in its state of rest, in its state of rest or state of motion, rotatory motion. And from the example of fan, I think we have got it. Actually, we use somewhere to make rotary motion possible, some fly wheels, our heat engines have wheel which rotates without belt that help with movement of inertia of that wheel, help the wheel to rotate, etc. But then how to measure inertia? In physics, the great problem that we measure everything. So moment of inertia of different bodies have got different values. It also depends on the acceleration. For simplicity, I take here first of all, here is the acceleration. A particular mass m. A particle mass m rotates about this acceleration. Just to understand, now it rotates in this along the circular path. Sorry, diagram बनने में थोड़ी दिक्कत तो होती है. It is circular path and it is acceleration. This is the radius r. This is mass m here. Point mass m rotates about this acceleration. Axis of rotation. It is circle, horizontal circle, axis vertical, passing through like this. So, if a body, if a point mass m rotates about an axis at distance r from the axis, then moment of inertia of point mass about the axis of rotation is given by capital I is used for moment of inertia. I is equal to mr square. The product of mass and square of distance from axis rotation gives the measurement of moment of inertia of point mass. We have taken it just to understand the meaning. Otherwise, bodies are not always point mass. You have bodies of different shape and size and different mass. So I mean to say here that moment of inertia does not depend only on mass. The other effect which affect by larger margin is distance from square of the radius, the square of the distance. If I bring it closer here, so it will be less. And you can feel, I will tell you, the moment of inertia of point mass rotating circular path about this acceleration is given by I equal to mr square. SI unit, it is scalar quantity. Inertia, moment of inertia. Moment of inertia is scalar quantity. Its unit is kg meter square. Now, what is the role of inertia? Sorry, what is the role of moment of inertia? What is the physical significance of moment of inertia? The moment of inertia in rotatory motion plays the same role as inertia in linear motion. By inertia, body opposes any change in state of linear motion or state of rest. Similarly, moment of inertia opposes any change in state of rotatory motion. Listen to me very carefully. Actually, physics has to be understood first, and then we should try to tell it how to tell the people. The moment of inertia is okay, the property of mass, but other factor is the square of distance from axis rotation. And moment of inertia plays the same role in rotatory motion as inertia in linear motion. Now, there are other things about moment of inertia. Suppose we have rigid, I told you rigid body is that if we apply force at any point of the body, either there occur no change in state of rest of any particle, or if there occur change, then every particle should be equally displaced. So if we have a rigid body like this, and it rotates about this axis, here the axial rotation पास of this, ये यहाँ से ये सॉरी ये नहीं axial rotation, इस पॉइंट से पास हो रही है रोटेशन, you can say point of rotation around which body can rotate, rotation. Now, moment of inertia of rigid body, moment of inertia of rigid body. Rigid body. So this body rotate, it can rotate like this. Then how to calculate? We can assume it to be made up of so many particles, whose distances are r1, m2, distance r2, m3, distance r3, m4, m5, m7, m6, like this. And just by definition of moment of inertia of point mass about an axis, so to find moment of inertia, of a rigid body about an axis passing through this point O, passing through point of rotation as shown in figure. We assume the body to be made up of many particles whose masses are m1, m2, m3, m4, so on up to mn, whose distance is from rotation, whose distance is from axis of rotation are respectively R1, R2, R3, R4, so on up to Rn. Then the moment of inertia of body about given axis of rotation will be given by I equal to m1 r1 square plus m2 r2 square plus m3 r3 square plus so on up to mn rn square. Which we write here like this: summation I equal to 1 to n or mi ri square. I will give one example, you will understand. So simply a theory just to understand. Like this body made up of so many parts, movement of inertia, this about the axis here, m1 r1 square, m2 r2 square, m3 r3 square, and when we add all of them, we get movement of the whole body. Now you must understand this summation. Because summation I write summation x I equal to, suppose I write I equal to 1 to 10. It means x1 plus x2 plus x3 plus x4 up to x10. ये मतलब इसका. Try to understand what is the summation means. Now, where do we apply this concept? Suppose you want to find moment of inertia of a ring. Ring we have seen, circular ring. Whose mass concentrated at its circumference. It is the ring here. I have shown little electrical. It is called axis rotation is like this. Anyhow it is. It rotates. So what we do to find moment of inertia, we take this as mass element delta m और ये r square. तो फिर यहाँ पे ले डेल्टा m square, फिर यहाँ डेल्टा m, we take so many. Then moment of inertia of this ring about this axis x dash क्या होगा भाई? डेल्टा m square प्लस डेल्टा m square सारे इक्वल लीजिए मास में और सबको हमने फाइनली जोड़ा तो समीशन डेल्टा m r square. Summation delta m is mass of the total mass of ring. Suppose that is capital M. So I equal to mr square. And this technique of calculating moment of inertia is later converted into integration method. So that derivation is not in syllabus only. We have to learn moment of inertia of different body. In coming video I will be giving that. So unit of moment of inertia kg meter square, and it is a property of body which opposes any change in state of rest or change of rotatory motion. Thank you.